All right, so let's talk about factoring the sum and difference of perfect cubes. So the first thing that I want you to do is understand what a perfect cube is. So we're going to fill out this table at the bottom of your note sheet. Of course, if you don't have this note sheet in front of you, just write these down. What does 1 to the third power or 1 cubed mean? It just means 1 times 1 times 1, which of course is 1. So 1 is a perfect cube. 2 cubed means 2 times 2 times 2. And 2 times 2 is 4, times 2 again gives us 8. So 8 is a perfect cube. 3 cubed, or 3 to the third power, is 3 times 3 times 3, which when we multiply all those together gives us 27. Shh, kitty, be quiet. I'm trying to do math. Come here. Now 4 to the third power, that's the same thing as saying 4 times 4 times 4, which gives us 64. And then we have 5 to the third power, which is just 5 times 5 times 5, which gives us 125. All right, so those are your first 5 perfect cubes. So let's keep going. What is 6 to the third power? That is 216. So 216 is a perfect cube. 7 to the third power is 343. So that 343 is a perfect cube. 8 to the third power gives us 512. So 512 is a perfect cube. 9 to the third power is 729. So that is a perfect cube. And then 10 to the third power is 1,000. So 1,000 is a perfect cube. So we see all of these values and we know these are all perfect cubes, and we can go backwards to find the cube root, or to find the value that creates them. Now, if you're given a big number, so let's say 200, well, let's do 2,400, and we want to know if it's a perfect cube or not, you can just use your calculator. But instead of taking the square root, we are going to take the cube root. This number right here is called our index. We need that to be a 3. Okay, so the cube root of 2,400 does not give us a whole number. Therefore, it's not a perfect cube. All right, moving back up here. So what I want us to do next is to go ahead and multiply together. Multiply together this binomial times this trinomial. And let's see if we can't see a pattern. We have 4x squared minus 6x plus 9. And we're going to multiply that by 2x plus 3. Okay, so we end up with 3 columns and 2 rows. And remember, to get each box, all we do is look up to the very top and left to the very left and figure out what we're multiplying together. So our first box, 4x squared times 2x, gives us 8x cubed. Our next box, negative 6x times 2x, gives us negative 12x squared. And if you need to go over this, I have a video on multiplying polynomials you can review also. We have plus 18x plus 12x squared minus 18x plus 27. And from this point, we need to figure out what our like terms are. I see I have 2 squares with an x squared term. And then I have 2 other squares that both have an x term. And I notice that when I combine these together, 12x squared minus 12x squared goes to 0, and negative 18x minus 18x goes to 0. So our answer for this problem is 8x cubed plus 27. And hopefully you recognize 8 and 27 as perfect cubes. We listed those at the bottom of our note sheet a minute ago. And of course, x to the third power is a perfect cube. So let's see if we can't recognize a pattern here. Okay, so 2x plus 3. What is the cube root of 8? Well, 2 is the cube root of 8. What is the cube root of 27? 3 is the cube root of 27. And what is the cube root of x to the third power? Just this x value. So that's how we get our first binomial. How do we get the second binomial? The second set of parentheses is a trinomial. What is 2x times 2x? That gives us 4x squared. What is 3 times 3? That gives us 9. And what is 2x times 3? That gives us our 6x. So really, all we need to worry about are the signs. So right here, I have these patterns written out for you. Ax cubed plus bx cubed, or ax cubed minus bx cubed. Go ahead and take a look at the pattern. And the only differences that we see are our signs. So if you're asked to memorize these, I want you to just kind of play with it and recognize the pattern. The A's and the B's are pretty easy to figure out, but a lot of times it's hard to determine which ones are pluses and minuses and all that good stuff. So we're going to use in our class the acronym SOAP. Oops, I want to use a pen, not a highlighter. SOAP. SOAP, to help us remember how our signs go in this factoring. The S stands for same. The O stands for opposite. The A is for always. And the P stands for positive. So if you look at these problems, if I start with an addition problem, the first sign is the same, the second sign is opposite, and the last is always positive. If we started with a minus problem, the first sign is the same, the second one is opposite, and the last one is always positive. So that's how the sign patterns work. So let's just do 4 quick examples. 2x cubed plus 54. What do we always do first? Look for a GCF. Both of these terms are divisible by the number 2. So we're going to go ahead and factor out our 2, and we're left with x cubed plus 27. Hallelujah. Both of those are perfect cubes. So we're going to use our pattern. And I found for me, it is easiest to set up a parentheses that represents a binomial and then one that's a little bit bigger that represents a trinomial. So x to the third power, its cube root is just x. 27 to the third power, its cube root is just 3. All right, now what is x times x? That gives us x squared. What is 3 times 3? That gives us 9. Now let's multiply x and 3 together, and that gives us a 3x. And all that's left is to determine our signs. Remember SOAP, same, opposite, always positive. Our first sign is the same as our original, so it's a plus. The second sign is opposite, so minus, and the last is always positive. And that is how we factored the difference of these two perfect cubes. That's our answer right there. Let's look at example 2. Oops, I didn't mean to do that. Example 2, it says 27x cubed minus 1,000. So we inspect that, we look at it, and we say, nope, there's no common factor there. But 27x cubed and 1,000 are both perfect cubes. So I'm going to go ahead and set up my binomial parentheses and my trinomial parentheses. So what is the cube root of 27? If you look back at the bottom of your paper, we see that is a 3. What is the cube root of x cubed? That is just an x. What is the cube root of 1,000? That is just a 10. Now let's multiply. What is 3x times 3x? That gives us 9x squared. What is 10 times 10? That gives us 100. And we multiply together 3x times 10, we get a 30x, and that's what goes in the center. Now let's determine our signs. We started with a minus, so our first sign is the same minus, opposite, plus, always positive. And we have factored successfully. Look at our third example. When I look at this one, 24m to the third power minus 3, I say, oh, Okay, both of those values, those number values, this coefficient and this constant are divisible by the number 3. So I will go ahead and factor that out. But what's left over? We have an 8m to the third power minus 1. 8m to the third power minus 1. If I look at those two values, I recognize, of course, our variable is cubed, but 8 and 1 are at the bottom of our list. Those are both perfect cubes. So how can I factor that? With a binomial and a trinomial. The cube root of 8 is 2. The cube root of m to the third power is just m. And the cube root of 1 is just 1. So let's determine the rest of our values. 2m times 2m is 4m squared. 1 times 1 is just 1. And when we multiply together 2m times 1, we get 2m. So now let's determine our signs. SOAP, same, opposite, always positive. The first sign comes from our original problem, same, minus, opposite, plus, always positive. And you silly goose, don't forget to bring down your GCF. And there we go. All right, one last example because I know you're having a riveting time factoring these sum and difference of perfect cubes. I know I am. Okay, 2d to the third power plus 128. Both of those numbers are even, so of course we can divide out a 2 from both of them. And we are left with d to the third power plus 64. Is 64 a perfect cube? Of course it is. It's written at the bottom of our paper. The cube root of 64 is just 4. So I set up my binomial and my trinomial. The cube root of d cubed is just d. The cube root of 64 is 4. All right, what is d times d? D squared. What is 4 times 4? 16. What is d times 4? That gives us 4d. And now we just determine our signs. SOAP, same as our original, opposite, always positive. Don't forget to bring down your GCF, and you are finished. And that's how you factor the sum and difference of perfect cubes.